Zaharul Islam. Zaharul Islam. Kuni asa?
Hai sir. Kuni asa sir.
Rohanjit Pal. Rohanjit Pal. Are you hearing? Nur Salim.
Yes sir.
Kuni asa?
Nur Salim present sir.
Present. Okay. Rohanjit present. Sorna Dotto. Kuni asa? Okay.
Awesome.
Mohor Boro. Mohor Boro. Omit. Omit. Mohor Boro. Omit. Firdusi. Hello Firdusi. Hello Firdusi. Michael Bosumotari. Momin Ali. Momin Ali. Momin Ali. Krishna Saha. Krishna Saha. Krishna Saha. Subhabrata Ghosh. Subhabrata. Hello, Subhabrata. Hello, Krishna. শুনি আছা? কিমানে জয়েন কৰিছে দেখা পাইছা স্ক্ৰিনত? কিমানে জয়েন কৰিছে স্ক্ৰিনত দেখা পাইছা?
Hello, sir.
12.
12.
12 joining. Amit Burman. Amit Burman.
Yes, sir.
Subhabrata listening.
Yes, sir. Yes, sir. I'm listening, sir.
Okay, let's start. Good morning to everybody. Good morning. Okay. Special theory of relativity. Already I have done 3-4 classes in our college classes. Most probably I have done up to Galilean transformation equations. Is not it? So I will repeat some equations here. So Galilean transformation equations. Galilean transformation equations. Suppose what was our equations? This is the frame S, okay, observer O. Another frame, this is S dash, observer O dash, okay. So it was moving with relative velocity V with respect to frame S, which is non-relativistic speed. Suppose you have a point A here. What is the coordinate with respect to frame S? S, X, Y, Z, T, and with respect to frame S dash? Babylina Burman. Babylina Burman. And with respect to Orof Laha. With respect to frame S dash, the coordinates are X dash, Y dash, Z dash, T dash. Then this is the distance, X distance, and this is our X dash distance. Suppose for simplicity, for simple calculation, the frame S dash was moving along X direction only. Along X direction only. Then what were our equations? The transformation equations that were X dash X minus Vt, Y dash is equal to Y, Z dash is equal to Z, T dash is equal to Z. So these were Galilean transformation equations. Okay. Then these are called direct Galilean transformation equations. Galilean transformation equations, GTE, direct. Now we can write like this: X is equal to X dash plus pt dash, y is equal to y dash, so y dash, z is equal to z dash, t is equal to t dash. So these were called inverse relations. Galilean transformation inverse, Galilean transformation equation. Already you know this relation. So देखिए ऐसा border देखिए ऐसा. So what were our results according to Galilean transformation equations? What we got? So number 1, length is invariant. Length is invariant. Itu number. Then দৈর্ঘ্য একে থাকে. Number 2, velocity is not invariant. Velocity is not invariant. Number 2. And number 3, acceleration was invariant. Invariant means if a particular physical quantity remains same, then this is called invariant. If they change after coordinate transformation, this is called not invariant. Okay. So in our earlier Galilean transformation equations, which were non-relativistic equations, and we got length was invariant, then length একেই থাকে, velocity change হয়, আৰু ত্বৰণ acceleration একেই থাকে. So these were our Galilean transformation equations. Okay. Then these were derived in our classes at college. Now I have given you the videos how to derive Lorentz transformation equations. Lorentz transformation equations, or these are called Lorentz-Einstein's transformation equations. So these are relativistic equations. Again, let me consider the two frames. Okay, two frames. This is frame S and this is S dash, observer O dash. Okay, so it is moving with relativistic velocity v. That means velocity which is comparable to the velocity of light. So for our simplicity, we consider the frame S dash moving along x directions. Okay. Now here let us consider a point A. So coordinates of point A with respect to frame S are x, y, z, t, and that with respect to S dash was x dash, y dash, z dash, t dash. Border देखिए ऐसा, border complete. देखिए ऐसा border complete. नूर सलीम देखिए ऐसा.
Sir, no right no camera to sir.
हाँ. এইফালে দেখা নাই. এইফালে দেখা নাই.
हाँ sir, এইফালে দেখা নাই.
Okay. এইখিনি দেখিছা up to this point?
No sir, no sir.
This?
No sir.
This?
দেখা পাইছো sir.
কোনখিনি দেখা পাইছা?
গোটেইখিনি দেখা পাইছো sir.
গোটেইখিনি দেখা পাইছা?
হয় sir. গোটেইখিনি কি দেখা পাইছো sir?
কোনকৈ দেখা নাই তাৰমানে?
T dash লৈকে.
Up to T dash, have you seen up to T dash? I think you must see. T dash seen, no? Is not it? Okay. So somebody's mobile is in lock system, rotation lock. So you move, unlock, rotation unlock. Okay. Make rotation unlock. So this was then what was our equations, transformation equations? X dash is equal to x minus vt under root 1 minus v square by c square. Y dash is equal to y. Z dash is equal to z. And t dash is equal to, this is different, t minus v square, v by c square x under root 1 minus v square by c square. These were the Lorentz direct transformation equations. Lorentz direct transformation equations. Okay. So you have to remember these relations. Here t dash not equal to t. When the frame adjusts most with relativistic speed, what happens? The time is no longer a constant quantity. Time is dependent. Time is coordinate dependent. Okay. So these are called Lorentz direct transformation equations. Lorentz direct. These are direct transformation equations. Already you know. I have derived in your video classes, YouTube classes. So thus I have mentioned the equations. Now what are the inverse relations? So x is equal to x dash plus phi t dash under root 1 minus phi square by c square. Y is equal to y dash, z is equal to z dash, t is equal to t is equal to, it will change, t dash plus phi by c square x dash under root 1 minus phi square by c square. These were inverse transformation equations. Inverse transformation equations. So already I have derived these relations. Okay. So now, I will discuss the consequences of Lorentz transformation equations. Consequences of Lorentz transformations equations or Lorentz transformation. Here follow key. Lorentz transformation consequences ki hobo. First ami paisilo number 1 length contraction. Length contraction. So important length contraction. That dorgosity hoy. Moi agote class oto koisu. Suppose this is your marker. If it travels with a speed that is comparable to the speed of light, then what happens? It becomes shorter. Like this. It becomes shorter. So how mathematically we can prove it? Mathematically Einstein to prove for it. So here what happens? Again you consider two frames of references. Okay. Again you consider two. You can write down this. Two frames of references. Observer O. Observer O dash. This is frame S. This is frame S dash. Okay. For simplicity, they are traveling along the x direction only. And now it is moving with relativistic speed p. Okay. Let us consider a length having positions. Suppose this is the length. This is position A, position B. Okay. Position B. So here suppose the x coordinate is x1, y coordinate is y, z, t. Okay, with respect to frame S. And with respect to frame S dash same coordinates are x1 dash, y, z, t. Y, z, t. Suppose for point B, so t dash, these are t dash. For point B, the coordinates with respect to frame S are suppose x2, y, z, t. And with respect to frame S dash, same coordinates are x2 dash, y dash, z dash, t dash. Have you written? দেখিছা তোমালোকে স্পষ্টভাৱে okay this is our x1 okay and this is our x2 okay and this is x1 dash and this is x2 dash. These are the coordinates. You write the this diagram. You got this diagram. So A and B. So length is AB. So coordinates of points A and B with respect to two frames of references are given. Here Y, Z, T. So we don't write these equations because we are only considering the positions only in x direction. Only x direction is changing. So we will ignore the other coordinates. So according to direct transformation equations, what is x1 dash is equal to x1 minus vt under root 1 minus v square by c square. What is x2 dash? X2 dash is equal to x2 minus vt okay under root 1 minus v square by c square. Is it clear? Picture clear ase? Picture clear raha paisa? Lehisa. So these two are the equations. So from here you will have x2 dash minus x1 dash is equal to what? Is equal to what? Moi khini musi disu. So x2 dash minus x1 dash. So this, so tolor to tomar eke thikibo. Okay. Under root 1 minus v square by c square. Here x2 minus x1. So vt minus minus plus vt, this will cancel out. So simply x2 minus x1. Okay. So this is suppose L dash is equal to L by under root 1 minus v square by c square. So this relation we have got. So what is L dash? L dash is the length measured with respect to frame S dash. What is L? L is the length measured with respect to frame S. Now you mind one thing, the length AB is stationary with respect to frame S dash. With respect to frame S dash, this is stationary. Length AB is stationary. That means L dash length is stationary with respect to frame S dash. That means the S dash frame is moving with relative velocity v. So what happens? Suppose this is our frame S dash, length is here. So this L dash length is moving with this, like this. It is moving like this. That means with respect to frame S dash, the length is stationary. Is not it clear, sir? With respect to moving frame, this length is stationary. So this length does not change. So this is the L dash is called your proper length. What is L dash? L is a length measured with respect to frame S dash. So L dash is the proper length. Prokito length. L dash is a proper length. What is L? This is the relativistic length. What is L? L is the length as measured by observer at frame S. L dash is the length as measured by the observer at S dash. That means measured by O dash, and L is the length measured by O observer at frame S. So with respect to which the length is moving with relativistic speed v. That means v is comparable to the speed of light. So from this relation, which one is greater? Which one is greater? Let's see. It I am here to explain to him. আমি এই ৰিলেশ্যনটো পালো here L dash proper length. What is L? Relativistic length. Relativistic length. Okay. Now here let for calculation, for understanding only, let what is V? 0.8 C. So what is this quantity? 1 minus V square by C square is equal to under root 1 minus 0.8 C square by C square, and this will come out to be what? 1 into 64. C square will cancel out, 0.64, and what will be this? This is 0.36. So this is what? Square root 0.6. Okay, is it clear? 0.6. So this term is 0.6. Now let's see what happens to this relation. Here, so what is L dash? L dash is equal to L by 0.6. 0.6, 10 by 6, that is approximately 1.7 L. What is L dash? 1.7 L. That means L dash is 1.7 times of L. So this relation implies what? L dash is greater than L. L dash is greater than L. That means L, this is the length as measured by O, which is in frame S. It is decreased. L is less. That means this implies that whenever the rod or length moves with relativistic speed, its length decreases. That is called length contraction. This is the length contraction. Okay, the length to tomar komi goi thake. This is our length contraction. Gote ami length contraction palo. Tarpor ami ইয়ার পরা কেটামান conclusion ami disilo. Conclusion keta ami explain kori. Conclusions. Or results. All results. Conclusions or results. Number 1. Number 1, tumar diye ase contraction is reciprocal. Contraction is reciprocal. Okay. Contraction is reciprocal. Reciprocal means, let me draw the diagram. Just you follow to understand. What do you mean by reciprocal? This is O dash, S dash, moving with relativistic speed X dash. Okay. Suppose this is the length. Okay. L dash with respect to frame S, and L is decreased. No, it is decreased. L with respect to frame S dash. So the observer O will see that the length has been decreased. Suppose you keep the same length here, equal to L dash. L is equal to L dash. You have two lengths of same length here, which is stationary with respect to frame S. Now O will see that the length has been decreased. It is contracted. If another rod, same length of rod is here with respect to frame S, which is stationary, then what will observer O dash will see this? Your length to ki dekha pabo? O dash a length to eke dekha pabo na beleg dekha pabo?
Contraction, sir.
Yes, contraction dekha pabo, because it is traveling with velocity V. But with respect to this, it is traveling with velocity minus V, opposite direction. Although it is stationary, but it will observe that he is stationary. O dash is stationary. O is moving. So with respect to O dash, it will see that O is moving with minus P. So if you put that value, okay, our relation was 1 by it. This was the relation 1 minus V square by C square. So relation is same, L by under root 1 minus P square by C square. So that's why I call the contraction is reciprocal. E jodi yak contract kora dekha paise, U yak thoka rod dalok contract kora dekha pabo. That is called contraction is reciprocal. Okay. How many joining have you seen in the screen? How many joining? Kimana join korise? 18?
18, sir.
18?
Yes, sir.
Okay. গটিকে এটো ফার্স্ট এটো তোমালোক দিয়া আছে এটা বুজিবলৈ চেষ্টা কৰবা ভিডিওটো চাবা গটিকে কন্ট্ৰাকশন ইজ ৰেচিপ্ৰকেল এটো হ'ল কন্ট্ৰাকশন